Hello students, good evening all of you. For a minute. Hello students, welcome to Unacademy, the largest online learning platform in India. So today evening, I'm glad to have a YouTube live with all of you. And myself, Krishna Prakash, students love to call me as a KP sir, and some people call me as a EE sir. I'm going to teach the subjects of environmental engineering, hydrology, irrigation. I have 10 years of GATE and ES experience. Most of the students know about me very well. And damn sure whatever I teach, if you go through my classes, surely all questions related to my subject, 100% you solve in your GATE and IS examinations. And I have 16 years of teaching experience. Now, I trained, out of this total 10 years of GATE and ES experience, I have trained around 150 batches of students and thousands of students, several thousands of students I trained and I helped them to get top ranks in GATE and IS. I am ex-faculty of ACE Engineering Academy. I also worked previously in Vani Institute, GATE Forum and other coaching centers. So, hi Krishna, hello. Then, today our topic is related to our topic is related to air pollution. So this air pollution is the subject for civil engineering students. Air pollution is the subject for GATE and ESE technical students, civil engineering students, GATE and ESE technical subject. And also it is important in ESE general studies, the subject of energy and environment. In the subject of energy and environment for all branches students. Clear? For all branch students in the subject of energy and environment, we have air pollution. So this topic of air pollution is very important for you for your BTech, for your GATE and ESE examination. So how much important this topic is? First, let us see how much important this topic of air pollution. So first of all, we are discussing for GATE, ESE, how much important this air pollution topic is. So this subject, this topic air pollution, important for civil engineering students, and you have 2 to 3 marks from air pollution. Surely one theoretical question and surely one numerical question. Sometimes they may give only one numerical. That means 2 marks mandatory. Must, if you observe the recent trend of GATE and ESE previous papers, especially if you go for GATE, if you discuss in terms of marks, you will have 1-2 marks question. And the same model ESE, technical paper 2 for civil engineering. Paper 2 for civil engineering, you have 2 questions. And ESE, paper 1, general studies paper. Clear? ESE, paper 1, general studies, which is for common for all branch students. This General Studies technical paper is common for all branch students. In that we have the subject called energy and environment. Energy and environment. Again, in this paper also you have two questions. Clear? In this paper also you have two questions. For GATE and ESC, especially if you go for civil engineering students, two questions in ESC from technical, two questions. That means as a whole, for a civil engineering student from air pollution, paper 1 and paper 2 combinedly, in ESC he is going to write 4 questions. In paper 1 2 question, paper 2 2 question, mostly you will get 4 questions from air pollution topic. For other branches with respect to energy and environment, we have 2 questions. Okay. So today what we are going to discuss means air pollution we are going to study. So we are going to discuss air pollution in the form of 5 parts, 5 days. It is not going to be completed in a single day. Air pollution is a big concept, very important concept. It is not going to be finished in 1 day, 1 hour. We are going to have 5 lessons, 5 parts of air pollution. If required, we may extend 1 day or 1 more day also. 5 hours, 5 parts of air pollution we are going to discuss. Thank you, Prakash 1995. Thank you very much for your comment. Then concepts what we are going to discuss under air pollution. First, air pollution. What is air pollution? What are pollutants? What are the causes of air pollution? What are types of air pollution we are discussing? Pollution, introduction, air pollution, its causes and its types of causes. Then pollutants, air pollutants, the chemical or physical impurity which is responsible to impart pollution, that is said to be pollutant. What are different air pollutants, their types and their effects? Then we are going to discuss concentration units and their conversion. So this is important for numerical questions, especially for civil engineering students. In energy and environment, you can focus on these theoretical concepts, ESC. ESC students, energy environment paper 1, you focus on this theoretical concepts. Then civil engineering GATE and ESC technical paper, you focus on concentration units and their conversions. And it is important for both ESC technical paper and general studies paper, and also GATE technical paper of civil engineering for both. Very, very important topic. Nowhere in your colleges faculty will teach you meteorological factors affecting air pollution. Yes, very good, Deepak. Your observation is good. 2020 ESC 4 questions in prelims examination from air pollution. Just before I said, for ESC 4 questions for civil engineers, for ESC 4 questions from air pollution 2020. Recent, just Deepak commented on it. Recent, we have 4 questions. Meteorological factors. Remember, don't miss this topic because meteorological factors affecting air pollution you can't find in local other textbooks, you can't find in Google searches, and your college faculty also not going to teach. Local coaching centers, not famous coaching centers, faculty also not going to teach. So this is the most important. No one knows clarity regarding this. But by the end of my class, I promise you, you will get 100% concept clarity regarding meteorological concepts affecting, factors affecting air pollution. Then also we are discussing about plume behavior. In this meteorological factors only, this plume behavior theoretical questions and also other numerical aspects are very important. Then finally, air pollution control devices. These are recent questions in air pollution, especially appearing in GATE numerical questions. Maybe some theoretical question in ESC, but recent questions mostly they are going to ask. Hi Gopi Satish Malla. Recently, they are going to ask this model of air pollution control devices questions. Now, good evening, Gopi. Composition of atmosphere. Before going to discuss about air pollution, yes, Teja, it is very much helpful for government examinations, Teja, not only for GATE ESC, for all state government examinations also, SSC, JE, RRB, wherever, without question from air pollution, there is no paper. Even general studies paper also, one question from air pollution is mandatory, Teja. Deepak Kumar, what you expressed is very good, very correct. Meteorological factors is a tough topic. So I will make that tough topic very simple for you. I have written clearly, this is important also and tough also. I will make that topic very easy for you. So before going to discuss what is air pollution, what are the effects and all those things, complete concept. First of all, we need to know about atmosphere. So atmosphere is the zone of environment. Atmosphere is the zone of environment that comprises, what it comprises? Gases. Atmosphere is the zone of environment which comprises gases. And these gases, depending upon the composition, based on composition, we have differentiated into major gases, minor gases. Based on composition, the atmospheric gases classified into major gases and minor gases. Major gases, 3: nitrogen, oxygen and argon. We have given clearly composition in this picture. Nitrogen 78.08 for highest gas, the gas with the highest composition percentage in atmosphere, followed by oxygen 20.946%, argon 0.934. All the other gases, see, even they are not equal to 0.1, less than 0.1, all minor gases remaining. Depending upon composition, we have differentiated gases into major and minor gases. Major gases, nitrogen, oxygen and argon. Minor gases, all the remaining gases comes under minor gases. Carbon dioxide, neon, helium, methane. So major portion is occupied by nitrogen, followed by oxygen. Then 1% all other gases, very, very less concentration. And based on their behavior, clear, based on composition, we said major and minor gases. Based on their behavior, these gases are differentiated into fixed gases, variable gases. Based on their composition, these gases are differentiated into fixed gases and variable gases. What are fixed gases? The gases which does not alter, does not modify. Nitrogen, very good, Yogeshwar, does not alter percentage, their composition. The gases which does not alter their composition from time to time, with time to time, place to place, origin to origin, those which does not modify their percentage composition, those gases comes under fixed gases. We'll have the example, we'll give the example for fixed gases. Nitrogen, oxygen, argon, hydrogen, helium, neon. nitrogen, oxygen, argon, hydrogen, helium, neon. These comes under fixed gases. Variable, the name itself indicate. What the name itself indicate? The name itself indicate variable. Change, modify. What modifies? Their percentage, composition. Change their percentage or composition. Ashok Krishna, very good. Composition, time to time. With respect to time, those who are changing their percentages. Helium is the most stable gas. Yes, very good, correct, Vedant. Variable gases. So I am looking downward. Don't feel that I am copying. I am looking downward to check comments here. Okay. Based on your comments, I am going to respond. I am checking my mobile to look out regarding your comments only. Okay. Then those gases which change their percentage or composition time to time. For example, ozone, water vapor, carbon dioxide, oxides of sulfur, etc. Those gases which modify their percentage time to time. So gases available in the atmosphere, we have differentiated based on their behavior. Those which change their percentage, those are variable gases. Those which does not change their percentage time to time, fixed, stable, those are fixed stable gases. Which can change time to time, place to place, region to region, they modify their composition. Those are said to be variable gases. Then our problem is not with fixed gases. We don't have any problem with fixed gases. But change in composition of these variable gases mixed with other impurities in the atmosphere and environment resulted in new molecules, generated so much adverse effects on human life, plant life and animal life. The variable gases change, modify their composition. Clear? Variable gases change, modify their composition, deviate, mixed with other components in atmosphere. Clear? Deviate and mix with other components in atmosphere. Then release new molecules, contaminants into atmospheric air. Then atmospheric air will cause adverse effects. That is studied under air pollution. So I will write down here. Variable gases, other physical, chemical, biological. I think more adverse effects are due to oxides of sulfur and chlorine. Yes, correct, Dharam. Variable gases or other contaminants, physical, chemical, biological contaminants, which bring modifications in atmospheric air and cause adverse effects on human life. Adverse effects on human, plant or animal life, even including properties, then that phenomena we consider it as air pollution. That phenomena we conclude as air pollution. Got it? The change in composition of variable gases, whose composition combined with other impurity or some contaminants are generated, physical, chemical, biological contaminants in nature, which cause adverse effects on human life, plant life or animal life. And that phenomena, if that adverse effects are created, That phenomena we consider it as air pollution. Got it? Then we are going to know about, first of all, we are going to know about the structure of atmosphere. What is the structure of atmosphere? We are going to discuss. Atmosphere structure based on temperature levels, altitude with respect to altitude. So first of all, tell me, what is altitude? Altitude is a vertical rise, height. Very good. Ashok, Manoj and Prakash. So you keep my name also, Prakash. So height from MSL, height, Teja, Gopi. Very nice. Everyone is answering. Vertical rise, height from ground, elevation. Yes. Vertical rise from ground level, height from ground level, that is called altitude. So this altitude, clear, 0 to 12 kilometer altitude, exactly 0 to 12 kilometer altitude, we consider that zone as a troposphere. Exactly 0 to 12 kilometers altitude. Troposphere, very good, Banu Prakash. Troposphere, and this troposphere, very important question you need to remember regarding troposphere, the zone of atmosphere where most of the weather phenomena takes place. This is the question important for your examination. The zone of atmosphere where most of the weather phenomena takes place, that is said to be troposphere. Then 12 to 50 kilometers or 48 kilometers, we can give 12 to 48 kilometers, stratosphere. Stratosphere, which is said to be zone of ozone layer. Everyone knows about ozone layer very well. So the zone of ozone layer, 12 to 48 kilometers, that is said to be zone of ozone layer. Then 48 kilometer to 84 or 86 kilometers, 84 to 86 kilometers, will consider mesosphere. Mesosphere, with increase of height altitude, it increases its temperature. Thereafter, up to 120 kilometer, thermosphere, where most of photochemical reactions, ionic interactions, photochemical reactions are going to take place. So 0 to 12 kilometer troposphere, 12 to 48 kilometer stratosphere, 48 to 84 kilometer mesosphere, and thereafter up to 120 kilometer thermosphere. This is vertical distribution of atmospheric zones with respect to temperature. Clear? Vertical distribution of atmospheric zones with respect to, clearly we are showing here temperature modifications. See here, stratosphere with altitude, temperature goes on increasing. Sometime temperature is maintained. This temperature is on x-axis now. So sometimes same temperature is maintained. Temperature fall down with rise of altitude in the mesosphere. Clear? In stratosphere, temperature goes on increasing with rise of altitude. In mesosphere, temperature goes on decreasing. Again, thermosphere, temperature goes on increasing. So this is a temperature versus altitude graph in various 4 different zones of atmosphere. Is it clear? In 4 different zones of atmosphere, troposphere with increase of altitude, temperature fall down, clearly shown. Temperature fall down. In Stratosphere it goes on increasing, mesosphere it goes on decreasing, thermosphere it goes on again increasing. These are the 4 zones we have considered. So very important zone as we discussed. Stratosphere is a zone of. So we love ozone layer actually, because we are hearing this word of ozone layer since our 6th standard or 7th standard. We are hearing about it. Ozone layer is the protective layer of Earth's strata. It interacts with ultraviolet light radiation from sun and stops penetration of UV light, harmful UV light into the Earth surface. But actually, ozone is generated in the stratosphere. Clear? Actually, ozone is generated in the stratosphere. Stratospheric oxygen, this is oxygen O2 molecule. This is oxygen 1, oxygen 2, 2 oxygen molecules. Got it? Oxygen O2, stratospheric oxygen, interacted with ultraviolet light radiation, sunlight. Harmful ultraviolet solar radiation splashed, interacted with oxygen and break down oxygen into 2 nascent oxygen free radicals. Here, oxygen is breakdown into 2 nascent oxygen free radicals. These nascent oxygen free radicals reacts with another oxygen molecule, generated ozone. Generated ozone molecule. Same here also. This nascent oxygen free radical interacted with another ozone, generated ozone molecule. So when we write down the chemical reaction, totally how many oxygens? Here 1 oxygen, 2 oxygen, 3 oxygens. So 3 oxygen molecules in presence of harmful ultraviolet light radiation, which is a solar radiation, resulted formation of 2 ozone molecules. Here 3 oxygen molecules, finally total na? Step 1, step 2 combinedly. Step 1 1 oxygen, step 2 2 oxygens combinedly. Total 3 oxygen molecules are generated. Clear? Total 3 oxygen molecules are generated. React with a harmful ultraviolet light radiation, generated 2 ozone molecules. So like that generated ozone, accumulated, converted into stratospheric ozone. That stratospheric ozone is forming ozone layer. So this is the question given in 2019 ESC General Studies examination. This question related to ozone. Which of the molecule is responsible to interact with ultraviolet light radiation in atmosphere? So it is not ozone. What is our answer? Stratospheric oxygen, which is reacting with UV light radiation. Stratospheric oxygen. Stratospheric oxygen is reacting with UV light radiation. But mostly we are going to answer ozone. Ozone is not the answer. Remember it. Ozone is not the answer. Stratospheric oxygen. This is given in General Studies paper 1, common for all branches. Stratospheric oxygen is responsible to interact with the UV light. Got it? Then I have a question. Will this stratospheric ozone is harmful or harmless? This stratospheric ozone, shall we say ozone is a pollutant? Is it not? Ozone is a pollutant. No? Then tell me whether this stratospheric ozone is a harmful or harmless ozone. Any one of you? Yogeshwar, harmful? Yes, harmful. Yogeshwar? Any others? Harmless. Gopi Satish, very good. Harmful. Ashok Krishna. Ramya, harmful. No. Dharam Dhanush. Good. So this is harmless. Stratospheric ozone is harmless. Clear? Because this is helpful to protect Earth's surface. This is originated, not helpful actually. This is generated, originated as a protection of Earth strata from harmful ultraviolet light radiation. This is harmless. But ozone layer which is formed, for example, take this is ground level. This is industry. Clear? This is industry. From industrial chimney, various gases are liberated. Due to chemical interaction of those gases, ozone generated 3 to 4 kilometers above ground level. What we call that ozone? What we call that ozone? I am writing here about that ozone. Troposphere ozone. Troposphere ozone. Ozone generated 3 to 4 kilometers or 5 kilometers away from ground level, from the ground level altitude 3 to 4 kilometers. Due to industrial chimneys, chemical interaction happened in the atmosphere. The chemical components reacted, volatile organic chemicals and nitrogen oxides chemically combined generated ozone. This troposphere ozone, very, very important, remember. What happened? Harmful ozone generated near to human living area in the troposphere. How? By industrial pollution as a secondary pollutant. By industrial pollutant as a secondary pollutant. That ozone more dangerous, harmful. But what about this stratosphere? Clearly we have written it is harmless. It is not at all, nowhere concerned with harmfulness. Stratospheric ozone is harmless. Tropospheric ozone is harmful. Then, coming for air pollution, why and how air pollution is going to take place? The primary reason for air pollution is combustion. Combustion is the primary reason for air pollution. So, we are burning fuels, elements in fuel, burned in air, elements in fuel. What the fuel will consist of? Fuel consists of carbon, hydrogen, sulfur, nitrogen, lead, mercury, ash. So, this fuel components, the fuel may be coal, kerosene oil, crude oil, petrol, diesel, whatever the fuel it may be. Some fuel from some sources combined with, mixed with atmospheric air containing nitrogen and oxygen, burnt. Then that burning of that fuel combining with air releases carbon dioxide, carbon monoxide, nitrogen oxide, sulfur oxides, lead, mercury, suspended particulate matter, RSPM, PM10, VOCs, volatile organic chemicals. All this we call it as pollutants. Especially they harm air, they modify air. These are air pollutants. Got it? Combustion. Combustion is the primary reason for any kind of air pollution. The fuel, carbon, hydrogen, sulfur, nitrogen, lead containing fuel, react with atmospheric air, nitrogen and oxygen, released air pollutants, various components we have listed here. Then, so for your reference, just I am giving definition. For your reference, just I am giving definition of air pollution. The phenomena of presence of physical, chemical or biological contaminants. Contaminants means impurities which modify original nature. The impurities which bring modifications in the original nature of environment, those are called contaminants, impurities. So some physical, chemical or biological impurities where in the air in some quantity, such quantity. This quantity is very important when those impurities exist greater than permissible means allowable limits. If they are less than allowable limits, no issue, we never thought, never think, no worries. Clear? If those physical, chemical and biological contaminants in the air, in such quantity, what quantity? In such means what quantity, you tell me? In quantities, concentrations greater than allowable limit, their concentration is more than allowable limit, and for long duration they stay in the atmosphere, stay for long duration in the atmosphere. Yes, greater than required, very good Ramya. Greater than accepted, greater than required, very good Ramya's concept, greater than required. Then they cause adverse effects on human, animal, plant life and also properties of human beings. Clear? Adverse effects on human life, animal life, plant life and also properties unreasonably interfere with comfortable usage of air. So unnecessarily they disturb taking of air by human beings, plants, animals and other properties. That phenomena we call it as air pollution. Students, got the clarity what is meant by air pollution, how it happened, why it happened? So the impurities, physical, chemical and biological impurity, more than required quantity, longer time duration spent in the atmosphere cause adverse effects on human, animal and plant life or cause damage to properties. That makes air not under comfortable condition. That is called air pollution. Then we are considering sources of air pollution. This is simply normally in some textbooks or some local authors, it was written types of air pollution. We may take it as a types of air pollution or we may consider it as a sources of air pollution. So air pollution basically classified into three categories. First one based on size, based on origin of source, based on origin of source from where the source is originated. Second one based on spatial distribution, how it was distributed in the atmosphere, and based on source position, where source is located. Depending upon the three categories, air pollution has been classified. Clear? Based on origin of source, based on spatial distribution, based on position of source. Based on origin of source, natural sources. Meaning of natural, no human involvement. Nowhere human is concerned with this air pollution. The natural factors like volcanoes, mist, forest fire, etc. So is any involvement of human in this? Yes, pollen grains also, Ashok Krishna, very good. Pollen grains also. We can have a list, no problem. So is there any involvement of human beings? Volcanoes, mist, forest fires, bacteria and other sources, natural sources? No, human not at all involved. That naturally, the nature will create air pollution, that is natural sources. Anthropogenic. Anthropogenic is nothing but man-made air pollution, man-made sources. So we know, everyone will say what are man-made sources. burning of fossil fuels, industrial pollutants, vehicular emissions. Even we include cigarette smoking also as an anthropogenic source, because it is also releasing considerable amount of carbon monoxide, sulfur dioxide chemicals. So anthropogenic sources, man-made sources, which include, already we discussed, industrial air pollutants, air pollution, vehicular emission, cigarette smoking, burning of fossil fuels, whatever it may be, human involved air pollution, anthropogenic sources. Then, based on spatial distribution, point source, nothing but a single source. Pollutants released from that only one source. There are not more than one source. Pollutants are released only from one source. Example, only one industry located in a village. So in the entire village, no more industries, only one industry located at the outskirts of the village. So how many points of air pollutants are released? How many points of sources of air pollution? Only one point of source. That one point of source, that is a single industry. Aerial sources. So pollutants are distributed spatially, huge area. Why pollutants are distributed spatially in huge area? Because number of sources are several, n. When n number of sources are there, we'll take a city. City consists of several industries. Where the several industries are located? In a industrial area. Spatially distributed air pollutants. Huge area, industrial area. Ashok Krishna, volcanoes. So volcano may be also single source, na? Ashok Krishna. Volcano is also a single source. It is not several sources. So industrial area consists of n number of sources. So aerially distributed air pollutant. Then, depending upon the location, position of source, stationary, the name itself, immovable source, static. The source always cause air pollution from a single static location. Immovable source, static location, not moving anywhere, immovable source. Example, again industry. Will industry moves anywhere? Will industry changes air pollution place to place, time to time? No. Once industry is constructed, the origin of air pollution from that industry is fixed at the same location. It is not at all varying. That is a static location, statically located source. Mobile sources, moving sources, simple. A truck moving on a highway. Will it cause air pollution at the same place? Vehicle, very good, Dhanush. Truck moving on a highway, will it cause air pollution in the same place every time? So it changes its location time to time. Mobile sources changes location of causing air pollution time to time. Changes location of causing air pollution from time to time. Got it? So these are the three basic categories of air pollution based on sources, based on origin, based on spatial distribution, and based on position of source. Now, shall we move on? So, types of air pollutants. So, what is air pollutant first? Tell me. I will write down here. air pollutant. I will write down the definition here. This is a physical, chemical or biological agent that contaminates atmospheric air, and cause what it causes? Adverse effects. Adverse effects on, as already we said, on human, plant or animal life. That is said to be air pollutant. That is said to be air pollutant. Yes, that is harmful for living beings if it is excess. Correct, Ramya? Contaminant, adverse effect means harmful only. Whatever I have given as a adverse effect, that adverse effect, this is nothing but harmfulness only, Ramya. Physical, chemical, biological agent that contaminates atmospheric air and cause adverse effects on human life, plant life and animal life. That is said to be air pollutant. Now again there is classification. I think you have got the clarity about definition. Now we have classification. Classification of air pollutants. First one, based on origin. Classification 1. Based on nature. Classification 2. Based on state of matter. Classification 3. So we come from the back end because first one is very huge. Elaborately we will discuss first one. So we will come from the back end. Based on state of matter. Particulates. Particulates are nothing but solid air pollutants. Solids. Like dust, fly ash, aerosols. These comes under solid air pollutants. Liquid. Liquid is mist. Even we'll take fog. Fog as a liquid air pollutant. Then third category, separately given gases. We can write down carbon dioxide, carbon monoxide, ozone, sulfur oxides, nitrogen oxides. We have a big list related to gases. Before I am going to give this classification, normally what you have thought in your brain, frankly telling, most of the people will feel air pollutant is a gas and it is a chemical molecule only. But remember, air pollutant is not only gas, it is a solid, liquid and gases, and not only chemical molecule, it may be physical, chemical and also biological molecule. Then based on chemical nature, air pollutants are differentiated into organic and inorganic. Organic air pollutants, hydrocarbons, volatile organic compounds, inorganic. Again we can write down n number of lists, n number of inorganic pollutants. Based on origin, primary and secondary. Primary, from directly from source. Directly from source. Secondarily, it is not released directly from source, indirectly. So primary air pollutant is the air pollutant released directly from the source, and in the same original chemical form it is going causing air pollution, causing adverse effects to human life. It is not at all modified, it is not at all changing its structure, chemical composition and all those things. Within its original form directly as released from the source. In the same original form it releases, causes air pollution. That is primary. For example, I will give best example. From burning of fossil fuels or some kind of coal, we'll take example. Burning of fossil fuel, carbon monoxide generated due to incomplete combustion. Carbon monoxide generated into atmosphere. Now this carbon monoxide gone for atmospheric tour. It visited troposphere, stratosphere, mesosphere, completed atmospheric tour for 1 to 2 years. Successfully completed, happily visited all zones, regions, places and returning back onto Earth. Without modification as carbon monoxide only, remember this point. Not chemically reacted, not physically reacted, returned back into the earth strata as carbon monoxide. Now it is causing air pollution, entered into human body, causing carboxyhemoglobin formation. So such kind of air pollutant, now carbon monoxide is called as a primary air pollutant. Then we consider secondary. From the same burning of fossil fuels, carbon dioxide is generated. Instead of carbon monoxide, now carbon dioxide is going to atmospheric tour. Okay. So previously carbon monoxide is gone to atmospheric tour, no change. The same original form it is entering into human body, causing problem to human life. Now carbon dioxide is released. It is gone into atmosphere, but during the journey, it may interact with water vapor available in the atmosphere. So carbon monoxide combined with water vapor in the atmosphere generated a new molecule. What is new molecule? H2CO3. Is it originated from the industry or fossil fuel? No. H2CO3 is originated from one primary air pollutant carbon dioxide, one atmospheric component water vapor mixed together generated acid rain, carbonic acid H2CO3 acid rain, which is secondary air pollutant. Got the difference now? If as it is released from a source, it gone and again entered into human body, causing damage to human, plant and animal life without modification, that is primary source. Then if it entered into atmosphere combined with other primary air pollutant or with atmospheric molecule, resulted a new molecule. That new molecule we call it as a secondary air pollutant. We'll give clear definition, primary air pollutant and secondary air pollutant. Air pollutant released from the source directly and cause adverse effects in the same original form as released from source. As released from source. So my dear students, there is a power cut here. I think my voice and screen is visible to you. My photo is not visible to you. No issue, within 2 minutes generator will be on. You will get everything live, no issue regarding that. Okay, we are going to continue the class. Air pollutant released from the source directly and cause adverse effects in the same original form as released from the source. Very important. Without modification. Without modification is called as what we call it as a so now what's on the video is called as primary air pollutant. Is called as primary air pollutant. Clear? Air pollutant released from the source directly and cause adverse effects in the same original form as released from source without modification. Primary air pollutant. Got it? Then very important, you need to by heart the examples, because you have one minimum question related to examples, mostly repeated question related to air pollution. Identify list of primary air pollutants in the below options. Identify list of secondary air pollutants in the below options. That is very important question. So we can write down carbon dioxide, carbon monoxide, oxides of nitrogen, oxides of sulfur, hydrocarbons, suspended particulate matter, SPM, we call it as SPM, suspended particulate matter. Then aerosols, mist, volcanoes, dust particles. We can write down even the biological pollutants like bacteria, pollens, smoke, soot, etc. All these components, these are comes under primary air pollutants. This list of primary air pollutants is very important for you students. Remember that carbon dioxide, carbon monoxide, oxides of nitrogen, oxides of sulfur, hydrocarbons, SPM, aerosols, mist, volcanoes, dust, bacteria, pollens and soot. Secondary air pollutants. The air pollutants generated, where generated? In atmosphere, not from the source, in atmosphere. How? Due to interaction of primary air pollutant with another primary air pollutant or with atmospheric factors, gases or water vapor. Atmospheric gases like oxygen, water vapor. And then what it causes? And then causes adverse effects. Clear? And then causes adverse effects. This is called secondary. Clear? The air pollutant generated in atmosphere. How it is generated? Chemical or physical interaction of two primary air pollutants or one primary air pollutant with any one of the atmospheric factors like oxygen or water vapor. then causes adverse effects coming down to ground level. That is said to be secondary. For example, from fuel burning, we'll take from fuel burning, carbon dioxide, sulfur dioxide, nitrogen dioxide are generated. All these are primary. Burning of fuel generated carbon dioxide, sulfur dioxide, nitrogen dioxide. Then when they enter into atmosphere, what happened in the atmosphere? Water vapor interacted. Then this carbon dioxide water vapor generated H2CO3, sulfur dioxide and H2O water vapor generated H2SO4, nitrogen dioxide and water vapor generated HNO3. These are said to be secondary. What we call it as? We call it as acid rain. Acid rain is a secondary air pollutant generated due to carbon dioxide, sulfur dioxide, nitrogen dioxide chemical reaction with water vapor available in the atmosphere. So this is secondary and this is primary. Clear? Then we will write down examples for secondary air pollutants. Clear? Examples for secondary air pollutants. So as just now discussed, acid rain, ozone, smog. Smog is smoke plus fog. Vog is sulfur dioxide with volatile organic compounds, or smog with volatile organic compounds generated vog. Pan is peroxy acetyl nitrate, PBN, peroxy butyl nitrate, PPN, peroxy propyl nitrate. So these are the examples for secondary. Very important, remember it. Example for secondary air pollutant. Acid rain, ozone, smog, pan, PBN, PPN and vog. Those comes under example for secondary air pollutants. So we'll continue tomorrow. Clear? Tomorrow again the same topic, air pollution on YouTube live. Whatever your doubts, my mobile is switched off. So if you have given in the comments any doubts, I'm not getting. So you do one thing, you text WhatsApp message to my number 9704571767. This is my WhatsApp number. If any doubts related to air pollution or any subject, you just text me WhatsApp message. I will send the reply and give the solution to you. And in Unacademy platform, I am going to teach civil engineering, environmental engineering, hydrology, irrigation, construction materials and management, open channel flow. And two of my friends from a big institutes also joined Unacademy. So we three combinedly going to complete entire GATE course, GATE or ESC course for civil engineering students. And in general studies I am going to teach ESC general studies. I am going to teach energy and environment. Clear? I told you already I have 150 plus batches training experience for GATE and ESC. I am top faculty in most of the GATE coaching centers in India. So now I joined Unacademy live classes. I'm going to teach environmental engineering, hydrology, irrigation, construction materials management of open channel flow for general studies, energy and environment. And my colleagues from big institutes also joined an academy. So we 3 members will complete entire GATE ESC Civil Engineering Technical course. So we provide 100% knowledge and we make you to get completely crack GATE and ESC examination in the first attempt, remember it. And if you want to subscribe an Academy Plus course, paid course, use my code KPCivil. Generally every faculty will say this, the faculty will provide you 10% discount. Only this is the benefit using the code with other faculty. But if you use my code, I will provide you free online test series. I have my own website. I will provide you free online test series for you. Any branch student, no issue. For each and every branch student, I will provide free online test series. I have free scanned copies of notes and other materials related to GATE and ESC. I will send you through mail, and my panel of faculty will support you throughout your career till you crack GATE and join PSU job, till you join your MTech in NITs and IITs. My panel of faculty will support you. And we have a WhatsApp group, Engineering Guru. In that Engineering Guru WhatsApp group, we clear the doubts. So many students, till now 1000 members of students are getting benefited through that WhatsApp group. So our panel of faculty will guide you for GATE preparation and also for post-GATE guidance. So if you use this code, just text me screenshot of your subscription. Immediately you get all the benefits whatever I mentioned. Okay. Tomorrow at what time? Tomorrow at 8:30 p.m. Again we are meeting on the YouTube live. Air pollution, same topic is continued for 5 or 6 days more. This is important for GATE and ESC Civil Engineering and also ESC General Studies. Students, remember, inform this to your other branch friends also. General Studies subject free live class on air pollution. You will get 2 questions from air pollution. Attend the class properly. Inform to your friends. Tomorrow we'll meet again. Until then, I'm signing off. Bye for today.